right, so we've been talking a lot about chemical reactions. We're going to kind of change gears a little bit and look at some of the math we have to do with different chemicals.
Okay.
So you know from real life that there are certain things that's just easier to think of in groups. Like when you get eggs, do you get like 5 eggs ever?
5 eggs. I get them in a pack of 12.
You get them back to 12, and what do we call that pack of 12 eggs?
A dozen.
A dozen eggs. Does it matter what I have if I've got a dozen of it? What do I always have if I have a dozen?
12.
You always have 12. So a dozen is just a way of telling you that it's 12. If it's a group you're going to use all the time, it's easier to give it a name. So, we talk about eggs in dozens. We talk about...
What about a baker's dozen?
Yeah, you get a baker's dozen get weird. So you can talk about eggs in dozens. What else? Donuts. You get dozen donuts. A dozen cookies. It doesn't matter. They're just 12 of whatever you have. Do you think we could usefully think of atoms in dozens?
Well, if atoms are really, 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 really tiny and I have to have enough of them to actually see them, I don't think 12 is going to be big enough.
Yeah, 12 is probably not a big enough group. And actually, atoms are so tiny, you have to have really, really big groups of atoms. So...
A really big group of atoms. I don't know what to call it.
Yeah, this probably isn't something you've dealt with before, because it's such a big group of atoms. It has to be its own thing. It's going to be a mole of atoms.
A mole of atoms? I've heard of a mole before. You mean like the rodent?
Yeah, but if you've got that kind of mole, it's
or
something
this
different.
kind of mole.
It's something very different. But if we're talking about a mole, like as the name for a group of a certain number, a group that contains a mole of particles contains 6.02 times 10 to the 23rd of that particle.
You should write this down.
That sounds like a really big number.
It is! So because it's times 10 to the 23rd, you take 602 and you put 21 more zeros after that.
Whoa.
So look at how big that is. It's huge. This is what kind of scale we have to talk about when we're talking about atoms, because they're so teeny tiny. All right. But no matter what we have a mole of, a mole is always 6.02 times 10 to the 23rd. That doesn't change. It's like a dozen is always 12.
Okay.
All right.
I got that.
So a mole is so big. It takes some thinking about how big that really is. If we had, for instance, a mole of marshmallows, it would cover the entire United States to a depth of several miles.
Whoa, that's a lot of marshmallows.
That's a lot of marshmallows. It's a really big number, but atoms are really tiny. So this is what we're thinking about. All right, so we've talked about moles, and we've talked about that they're generally groups of atoms. Do you think there's any way to get between the two?
Moles. Well, there must be.
There must be. So we're going to have to do some math. All right, so moles to atoms or any other kind of particles, we can actually use a triangle.
A triangle, okay.
And so
I like magic triangles.
Yes, magic triangles are good. This doesn't really look like a triangle, but the stuff we have to put in there is kind of big, so I didn't want to make it look all squished.
So it's the guts of the triangle.
Yeah. So whatever we're doing, on top is going to have to be our parts, and we're going to talk about what parts can be in a minute.
Okay.
On the bottom, we've got moles, and we also have 6.02 times 10 to the 23rd, because one mole is always 6.02 times 10 to the 23rd of whatever we're looking at.
Okay. Is there a special name for 6.02 times 10 to the 23rd?
Yes, there is actually. That is called Avogadro's number.
Avocado's number?
Nope, it's got a G.
Oh.
It's named after an Italian guy.
Okay.
Amadeo Avogadro. So this is actually Avogadro's number. So if anyone ever talks about Avogadro's number, we know we're talking about a mole of something. All right. So when we're using this, we need to know what our parts can be. So what did we talk about already that we could have a mole of?
Okay, well, we said atoms are teeny tiny, so atoms?
So we can have atoms. And if I put atoms together, what do I call that?
If it's covalent, a molecule?
So we can have molecules. That can be one thing that parts can mean. So atoms, molecules.
Let's see, we said covalent. Ionic is a formula unit?
Is a formula unit.
Man, you're taking me way back.
Mm-hmm.
Maybe could parts be particles?
It could actually be some kind of particle. Usually that will fall into one of your above categories, but sometimes particle really makes the most sense from what we're talking about.
Okay.
So anything that's teeny, teeny, tiny can be our parts. So if we're breaking it down from big group of things to parts, it can be one of these things. There are a couple others, but these are the ones that are going to show up most of the time.
Okay.
All right. So let's look at a problem with this. We want to know how many moles we have if we have 5.69 times 10 to the 24th formula units. And this is our first guided practice problem. So let's look at that. What does it tell us in that guided practice problem that I didn't write here?
Well, it says barium nitrate.
Barium nitrate, but it's a mole. Does it matter what I have if I'm doing barium nitrate?
I'm assuming not yet.
Not yet. So there are going to be places where it does, but for right now, we need to know that we're finding formula units. And formula units was a type of what?
Part.
Yeah, okay, when we're not finding formula units, we have formula units. So we have parts, and where did parts go in our triangle?
On the very top.
On the very top. So let's put our 5.69 times 10 to the 24 formula units on top.
Now, I noticed that you put a number in the triangle already when we went back to it. And it was Avogadro's number. So does that mean that that number always gets put in that bottom?
Anytime we're dealing with parts, no matter what parts we're dealing with, we've got to have 6.02 times 10 to the 23rd.
Would you say that's kind of like my conversion factor?
It's your conversion factor. It can also be thought of as a constant.
Ooh.
It's always going to be there. So if we're doing parts, we know we've got to put 6.02 times 10 to the 23rd down here. So all of the problems that you're doing in 7A1, you've got to make sure you put 6.02 times 10 to the 23rd right there, no matter whether you've got a number up here or a number on the bottom. So what was it that goes on the bottom?
It was moles, and that's what we were looking for. So that's kind of like my X or my question mark, right?
So what would you like me to put here?
Let's say an X, because I like X
All right.
best.
So we're looking for X, and X is our moles. And that's what our problem tells us we're looking for.
Okay, now, I know it's been a while since I've done one of these magic triangles, so I know I've got a number stacked one on top of the other, and when they're stacked one on top of the other, what do I do again for math?
So if I've got a number on a number, I'm going to divide.
Okay, on top of each other I divide, and side by side I...
Multiply.
Okay.
And we'll get to
okay.
multiplying here in a second. So for right now, we know we've got to divide.
Alright, and we put the biggest number in first, right?
No.
No! Oh, man.
We start at the top, we work down.
Alright. Read it like a book, top to bottom. Okay, so this is where you are going to need to grab a calculator if you haven't done so already. And we have scientific notation. Scientific notation is something that we did a long time ago. There was a special button that you had to use for times 10 to the power of, and that would be the E button, right?
So you're looking for the E button. So when we put this in our calculator, we're going to put 5.69 E, whatever that looks like on your calculator. And then we're going to put in our exponent. What's our exponent?
So E stands for times 10 to the and power of.
Yeah.
And so it would be 24.
Right, so this just means 5.69 times 10 to the 24th power. And then we said we were going to
Divide by
divide by
6.02 times 10 to the 23rd, so it'd be 6.02 E 23.
right, 6.02 E 23. And the reason we use our E's here is because otherwise if I divide by something times 10 to a power, it's going to do that at the very end. And then bad things are going to happen to our answer. All right, so we plug all that in.
All right, so I get this really long number. It's 9.451827243.
All right, in chemistry, when in doubt, give us 2 decimal places. 2 decimal places is usually plenty.
All right, so it's 9.45. I look at the number after the 5, which is a 1, which leaves 5 where it is. So we're going to say 9.45 is our answer.
All right?
And I can't have a naked number, so it's going to be moles.
Because that's what the problem said we were looking for. And you can actually abbreviate moles as MOL, but it doesn't save that much time, so I went ahead and wrote it out.
Okay.
So you can have 9.45 moles because we took parts and we divided by Avogadro's number.
This is pretty easy.
It is, you just plug it in. All right, let's try another one. So here we have 3.04 times 10 to the negative third moles, and we want to go 2 molecules. So we're going to start with our triangle. And so where do our moles go?
Moles go in the bottom on the left-hand side.
So we're going to have 3.04 times 10 to the minus 3 moles. All right, and what else always has to be in this triangle?
The constant number, 6.02 times 10 to the 23rd. Avogadro's number.
Because we've got a mole. And so we've got 6.02 times 10 to the 23rd of something.
Ooh, side by side, I multiply.
All right, so we know we're going to do 3.04 times 10. Oh, do I put times 10 in the calculator?
We're going to do the E button.
We're going to do the E button. E minus 3, make sure you're using actually the negative sign and not the minus, times 6.02 E 23.
All right.
So if I do that,
When I did my calculations, you said I need to do 2 decimal places.
2 decimal places.
So I got 1.84, but if I pay attention to my calculator, ooh, it's got a little teeny tiny times 10 to the 21st.
So it's actually at 1.83, and we've got to make sure we keep that.
Okay.
It's times 10, times 10 to the 21. And then no naked numbers again. What was I trying to find?
Let's see, it was parts are on top, but they gave me a specific title for parts, and it was molecules, so I'm probably going to have to spell that out and not abbreviate it, right? So
Right,
I'll
because
be
otherwise it's
confused.
get really confused with moles. All right, so we've got 1.83 times 10 to the 21st molecules.
Now, it goes guided questions 1, 2, and then it just says how many atoms of nitrogen.
So we're actually going to keep working with the number we just found. So we're going to put this back. And we know we just found that we had 1.83 times 10 to the 21 molecules
So,
of what exactly? Because this is where it becomes important.
dinitrogen pentoxide.
So what do I know about dinitrogen pentoxide?
Di means 2, so it would be 2 nitrogens.
So 2 nitrogens.
And penta, like a pentagon, is 5 oxygens.
So I've got 1.83 times 10 to the 21st molecules of N2O5. And it wants me to figure out how many atoms of nitrogen I have.
So do I go back to my formula for N2O5 and just count how many N's I have?
So for each one N2O5, I've got how many N's?
I've got 2 of them in there.
So if I'm trying to take it from molecules to some atom that's in my molecule,
So since I have 2 of them, do I just double it?
so I take my number. So for every 1.3 times 10 to the 21st molecules, I multiply it by 2 N's.
So if you still have your answer in the calculator from the last problem, all you have to do is press times, so we're working smarter, not harder, and multiply it by 2, and I got 3.66 times 10 to the 21st. And that would be atoms. And then do I need to put nitrogen on there?
It's generally best if you do.
Okay.
So that's atoms of nitrogen, because we want to be specific about what we're looking at. Because we're going to get to a point where we're trying to find atoms or parts of multiple things. So you want to be pretty clear.
Okay. Well, that was pretty easy.
All right. So now it's time to work on the problems on your own.
Have questions, ask.